Okay, good afternoon, and I'm He Yuyao, and this is the solution to the assignment 2. And here is the first question. The question A, is to calculate the limit result to derive a 96% confidence interval for theta. But in the question A, for the mu is unknown. Mu is unknown, so we need to use the MLE, and the mu is equal to x bar. And then, because we need to calculate the interval, so we need to calculate the standard error of theta bar. So, in order to calculate the standard error, we need to find the relationship between theta bar and theta and also the normal distributions. So we can use this to got the G mu is equal to this one, and then calculate the derivations, and then we can use the standard limit theorem and then have the relationship between x bar and mu limits to the normal distributions, and then we can use the delta methods, so we can get the relationship between g x bar and g mu. So g x bar is equal to theta bar, and g mu is equal to theta. And then they are limits to the normal distribution like this. This is the result. So we can get the expressions of g mu bar, and then we can get the standard error. So now we can get the confidence interval, and the confidence intervals we can divide it into two parts. The first part is the expression of theta bar, and just use the definitions. And the second part is about the standard error and multiple the exact part, exact 0.02, and then this is the confidence interval. Okay, the question B is similar, but the different one is in this part 10 is no, but the sigma square is unknown. So it is similarly, we can just use the MLE, and then we can sim sigma square as the S squared. And then similarly, because we need to calculate the standard error, so we need to get the relationship of the theta bar and theta. And then we can use the expression of g theta bar and to calculate the standard error. And then, but it is more difficult because the sigma square is unknown. So we can first to list out the expression of g sigma square, and then we can standardizations the x1. So the xi minus 10 can write it as this. And then we can use the yi to substitute the xi minus 10 squares. So we can calculate the yi is equal to sigma squared to plus this part squared, but this part is equal to 0, so we can count it as the result is sigma squared. And then we need to calculate the variance of yi. And in this part, this one is equal to the sigma squared, but this part we don't know. And then we can use the result of the normal distribution. We know that when we calculate the fourth and divide it by the sigma of the power 4 is equal to 3. So we can just calculate the variance of y1, and then we can take the y1 into the expression of s squared and the variance of s squared, and then we got the expressions. Then we can use the standard limits theorem and then to write the relationship between s squared and sigma squared, and then use the data methods to get the relationship between between sigma bar and the sigma. So we can got this relation, got these results, and then got the standard error, and then just write the interval. Just like the part A, you can divide it into two parts. The first part is the expressions of the sigma, and the second part is about the standard errors and multiple the z. Okay, this is the question 1. And question 2 is more easier than the question 1. We can just use the definitions of the normal distribution and the MLE can just solve these questions. And for question A, we can know that there is 4 positive data and 6 non-positive data in our sample, so we can just use the definition of MLE and we can calculate out the exact theta is equal to theta power 4 and 1 minus theta power 6. And then we take the LNs of the both sides of the equations at the same time, and we got the small l theta is equal to this one. And then we take the differentiations both sides of the equations at the same time, and we got the expression like this. Then when is equal to 0, we can calculate the theta is equal to 0.4, and then we know that the theta bar is equal to 0.4. And then the question B is to find an estimate of mu. But we know that the theta is equal to the p is at I greater than 0. And then we can just use the definition of natural distribution. We know that the p when xi is greater than 0 is equal to 1 minus p xi less than or equal than 0. So this part in natural expression, we can write it as this one. And then by the symmetry, we know that the expression of minus mu and 1 minus expression minus mu is equal to mu, because we can just use the graph and it is symmetry. So the top is 0 and this part is mu, and this part is minus mu. So 1 minus natural distribution of minus mu is equal to these areas, the yellow areas, and the positive mu is equal to this green area. So the two part is equal. Okay, and so when the natural expressions of mu is equal to 0.4, and we can just calculate, then we know that the answer is minus 0.2533. And that is the solution of the question 2. And next is the solution of question 3. And first, we need to find the mean and variance of x. And this can just use the definition of the mean and variance. And so EX is equal to 1 plus PX equal to 1, and then plus the 2 multiple the PX equal to 2, and then got this result. And then if we want to calculate the variance of x, we need to calculate this first part. Okay, and this first part is equal to this one, just by the simple definitions. And then we got the result easily of this. Okay, and for the question B, we need to prove that the theta and bar converge in probability to theta. So we can just use the definition of Wick law of large numbers, and by this definition, we can got the expression. We can got the expressions in the first line like this, and then so we can got another expression is like that. The x and 1 bar is converge in probability to the 2 divided by 2 minus theta. So we can just take the theta n bar into these expressions, that of this one. So it is probability concurrent to these expressions, and it is calculates is equal to the theta. Okay, and this is the part B. C. Now we need to use the xn bar to construct approximately of 95% CL for theta. So just like the question 1, we need to first calculate the standard error of xn bar. So that we need to calculate the variance of xn bar. Just use the data methods. But first, we need to calculate the xn bar first. And in the question C, we got 10 data. So we can count the xn bar is equal to 1.4, and then use the results in question B. We can count that the theta 10 bar is is equal to 0.572. And then we use the data methods. We got the xn bar is equal to this, and to calculate the deviations. And then to use the data methods, we can just simply the expressions and got the variance of theta 10 bar is equal to this expression. So we can just take to take all the expressions in these expressions. And then we calculate out the answer is equal to 0.025. So we can get the standard error is equal to 0.158. And so the interval is in this. Also, it is, we can divide it into two parts. The first part is the theta 10 bar, and the second part is about the standard errors and multiply the exact n. And then we can calculate the answer is like that. And at last, the question D is to comment the guess. But when we calculate this interval, we found the interval contains the true value of theta, but it is relative wide. It is so wide. So it reflected the higher uncertainty of the estimation when the sample size is too small, because it is just 10 data in the part C. Okay, so that is all of the solutions to the assignment 2.